Hello and welcome to a new session with edupediaworld.com, your favorite portal for online education. This session we shall start with a new series on project management techniques, wherein we'll see the two most common and most prominent project management techniques, which are the critical path method (CPM) and project evaluation and review technique (PERT). The topics which we shall be covering under this series are: first, we shall start with the introduction. Then we will see what is a network flow diagram. Now, network flow diagram are the basis for both critical path method and project evaluation and review technique. Then we'll see what is the CPM and PERT. We shall calculate the completion time of a project under both cases, PERT and CPM, using the backward and forward pass methods. And finally, we shall see how to calculate the slack or float time. Well, what do we have for this session? We shall start with the introduction, where we'll see what is a project and what is project management. Thereafter, we'll move on to network flow diagram and see what is a network flow diagram, how to draw a network flow diagram. We shall understand the precedence relationship, and at the end we shall take up a few problems on network flow diagram for practice. Here we go. What is a project? A project is an endeavor undertaken to create a unique product or service which is specific, timely and multidisciplinary. So we see that a project is an endeavor which is undertaken to create something which is unique. It is time bound, and various disciplines or various functions of an organization come together. It is a series of related jobs usually directed towards some major output and requiring a significant period of time to perform. In other words, we can say it is a set of activities with a defined start point and a defined end point, which pursues a defined goal and uses a defined set of resources. So we see that everything is predefined. We have the goal defined, we have the resources limited and defined, we have a specific start point and a specific end point. Now, what is project management? Project management is the planning, directing and controlling the various resources to meet the technical cost and time constraints of the given project. It is the application of knowledge, skills, tools and techniques to a broad range of activities in order to meet the requirements of a particular project. We understand that a project is different from usual business from these definitions. But what is that which differentiates it from usual business? Or in other words, what are the salient points or characteristics of a project? Well, first, a project has a specific purpose which can be clearly identified. It is time bound, it has a defined beginning and end. Further, it cuts across organizational functions, and various functions, various departments come together to pursue a project. It is unique and it is intended to be done only once. It's not repetitive in nature. Here we have a plan towards a clear intended result. We have resources allocated specifically to it which are limited, and it is not the usual routine. Further, it has cost constraints, and the focus is on the customer and customers' expectations. That is, it is something which is created unique, which is unique and which is created as per the expectation of the customer, done once, and it's not repetitive. Alright, so now let's move on to network flow diagram and see what is a network flow diagram. Well, a network flow diagram is the logically and sequentially connected arrows and nodes representing activities and events in a project. It's basically a diagram which uses various arrows and nodes to represent the sequential activities of a project. How do we get it? First, the entire project is broken down into smaller tasks called activities, and their sequential order of performance is determined. A network flow diagram is the graphic representation of these activities of the project using arrows and nodes based on the precedence relationship. This is also called as an arrow diagram. Now, what is precedence relationship? Precedence relationship tells us the sequence by which various activities of a project can be performed. It basically explains you which activity is to be performed before which activity or after which activity. An activity to be performed after another activity is called a successor, and an activity which is to be completed before the start of another activity is called its predecessor. We can also have activities which could be performed simultaneously. All of these are depicted in the network flow diagram. We basically have two types of network flow diagram. One which is called as the activity on node, and another activity on arrow. When an activity is represented on a node, it's called activity on node, and when an activity is represented on an arrow, it's called activity on arrow. We shall be using the activity on arrow network, AOA network. Let's see how both of these differ. Let's say, for example, we have a start point, say an 1 here. This is the instantaneous moment in time where I'm starting my activity, and then I have an activity, say A, which is represented using this arrow, and it ends at this point of time. I mark it with a node 2. This is our activity on arrow diagram. The same could be represented on activity on node diagram by simply marking this as A. Let's say we have two activities, one activity A followed by its successor activity B, and if we have to represent this on activity on node diagram, this will be A on node, which is an activity. The arrow here just tells us the direction in which we move, or it clarifies the precedence relationship, and then this is our activity B here using another node. So this is the difference between an activity on arrow and activity on node diagram. Okay. Now let's see an activity which is represented by an arrow. We have already seen that. We also have dummy activities which does not take any time or consume any resources for completion. It just represents the precedence relationship and used only when it is required. We shall understand the various rules of drawing a network flow diagram, where to use a dummy, how the arrow should be marked, how the nodes should be numbered when we practice a question. We have two types of events. An event in a network flow diagram is represented by a node, as we have seen just now. A merge event is when more than one activity ends at a particular event. and a burst event is when more than one activity starts at an event. Now, the numbering of an event in a network flow diagram is done in such a way that an event at the head of an activity is numbered higher than the event at the tail of the activity. Let's understand what are merge and burst activities. When we have a event, say 1, and if there are more than one activity emerging out from here, say A, B and C, then we call this as a burst event. And in case if we have a node where we have more than one activity ending, say A, B and C, then we call this as a merge event. Okay, let's move on. Let's just understand the common errors which we have in a network flow diagram. The first one is looping. It is the case of endless loop in a network flow diagram, which is also called cycling, and this error must be avoided. An activity here becomes the predecessor of itself, which practically is impossible. It's something like this. When you have, let's say we have event 1, an activity A emerges from this, goes up to node 2. Further from node 2 we have another activity, say B, going up to node 3, and then finally we have another activity, say C, which goes back to 1. Now this will end in cycling, which basically is not possible. This is called looping, and this is an error. The next is dangling. If an activity gets disconnected before the end of all the activities, then it is called dangling. Let me represent this. Let's say here we have activity 1, event 1, and the activity A starting from there goes up to activity A, event 2. Then we have another activity B, and so on till we have, say, to the last node from start. Now there could be one activity here, let's say activity C, which does not end with the loop to the logical end of the project. Rather, it just leaves out somewhere in between. This is called dangling. This is another error which must be avoided. And finally we have the redundant activity. When two or more parallel activities in a project have same head and tail events, then they are called redundant activities, and this can be represented by using a dummy. So here we'll see what is a dummy and what is a redundant activity. Let's say we have an event here 1 and 2, and we have an activity, say A and B. These two are parallel. We see that they have the same start and same end. This, if we leave it like this, is called as redundant. What we will have to do is, in these cases we will have to use a dummy, and this will be represented, say 1, and we have 2. We will have the activity A going from here to here, and then activity, say this is A, and activity B will be going from this point to here. Now here we'll have to write 2 because, and then we will have a dummy used from 2 to 3. So this is a dummy. Let me mark this with a different color. This one is your dummy. Okay, so this is the case of redundant activity. We can have other cases also, but for now let's keep it simple and let's just understand what is a redundant activity and when we use dummy. Further, when as and when we take various problems, we shall understand the usage of dummy in other cases. Alright, so now let's take up a problem. Here we have a practice question. You see here we have totally 10 activities starting from A to I. Sorry, there are 9 activities, and then we have the immediate predecessors of each activity is given, and further the time required to accomplish each of these activities are given in the third column. So let's take this question and let's see how to draw a network flow diagram for this. Okay, so here I have the question. I have first activity A, and we see that activity A has got no immediate predecessor. Okay, so we can start activity A straight away. Let me start it from say the first node. Here I have activity A. Now this takes 5 days, so let me write that here in parenthesis. A is followed by B. You see here activity B has its immediate predecessor as A, which means as we complete A, we are ready to start the activity B. So I can start my activity B at this node, say node 2. I'm ready to start with activity B, and B takes 7 days time, so let me mark that here. This is activity B and it takes 7 days. Next we have activity C followed by following activity B, and also we have activity D. So you see that now we have 2 activities, both C and D, which could be started immediately at the completion of activity B. So here when I've completed activity B and at node 3, I can take up 2 activities simultaneously. So I can draw 2 arrows from here, one representing activity C and another representing activity say D. Okay, and C takes 2 days time and D takes 3 days time to complete. Moving ahead, we have next activity E following activity C and activity F following D, but also we have activity G following C. So again we have 2, E and G, both following activity C. Yeah, you see here. So here from C again I have 2 activities, activity E and activity G. So let me put a node here, node 4, and from here we see that there are 2, activity G and E. Let me mark activity G here. This is activity G and activity E. Okay, G takes just 1 day to complete, and E takes, well, E also takes 1 day to complete. Now you see that the arrows are of different size. Well, let me tell you that the arrows are not drawn to scale with respect to time. Like here we have 2 days, here we have 1 day, here we have 3 days, but you see that all of these are of varied length. It's immaterial. The length of the arrow is not the representative of the time taken for that activity. Okay, so here we have G and E drawn. We have, let me say that we have got A, B, C, D. E is drawn, G is drawn. Now we have F. F is after activity D, that is here. So let me mark a node here as node 5, and here we can take up F. But let's move ahead little and see. We see that activity H is to be followed both, activity H has to follow both E and F, and activity I has to follow both G and H. So let's take this case first before we draw activity D. We see H is to be following both E and F. Here we have E, we have F, which has to emerge from node 5. Now if I have F drawn here like this, and let's say we have two nodes at these two places, the next activity H has to follow both of these. That means it has to start from here as well as from here, which is not possible because we cannot have one activity represented by more than one arrow. Okay, therefore what we understand is that these two should merge at one node. That is, activity E and activity F should merge at one node. Okay, many a times when you're drawing a network flow diagram, the first instant you may not get it in the most perfect form. You will have to refine it further. Okay, so here we have activity F, and that has to go and merge here with this. Activity F takes 2 days time, and this could be marked as node 6. Okay, so I'm done with F. Next is H. H follows both E and F. I have prepared ground for this. E and F. H has to follow E and F. Okay, and H takes 3 days to complete. But then when we move on to I, we see that I is to be started only after the completion of both G and H. So only after I complete G and H, at a point I can start with I. Therefore what we see is that these two again has to merge. Again a similar situation like how we had for E and F. Therefore let me redraw this H. Okay, and let me extend G so that we get a neat diagram. Okay, let me extend this. This is G and this is H, both merging at node 7, H taking 3 days. And finally we have activity I, which follows both G and H. Activity I could be started at this point. I and I takes 10 days time here, and we end at this node 8. Okay, hope it is clear. So this was one question we have seen in this session. We shall take up more questions in the upcoming sessions. Keep watching edupediaworld.com videos. Thank you.